if I have the integral of x to the negative 7, how would I do that from my rule? And so my rule, this is n is equal to negative 7. My rule would tell me that I do x to the negative 7 plus 1 divided by negative 7 plus 1 plus c, right? And so if I simplify this, I'll get x to the negative 6 over negative 6 plus c. And so the question you need to ask yourself to determine if you were right or not is, if I take the derivative of x to the negative 6 over negative 6 plus c, do I get what I started with? Do I get that x to the negative 7? And so let's check. All right, so d over dx of x to the negative 6 over negative 6 plus c. My negative 6 drops down, and I'll get negative 6, and then I subtract 1 from my power. I have a negative 6 down there, and my c goes away. These will cancel out, and I'll get x to the negative 7. So big check mark, right? That was good. How about if I get something like this square root? You might say, oh, we didn't get a rule for square root. What are you doing, crazy man? Well, turns out this is really x to the 1/2, which we've kind of used as a trick before, right? And so here I have n equals 1/2, and so my formula tells me that I would want x to the 1/2 plus 1 divided by 1/2 plus 1 plus c, which is going to be equal to x to the 3/2 over 3/2 plus c. Now I want to simplify this a little bit. You may not want to, but you're going to have to on the exams. So in general, when you have a fraction on the bottom like this, which will start to happen more, I want to multiply by the reciprocal of that fraction. So I'm going to multiply the top and the bottom of the fraction by 2/3. And so why does this work? Well, I'm really multiplying the fraction by 1. Anything divided by anything is 1, but it's kind of helpful here, right? Because this on the bottom here all cancels out, and I'll be left with 2/3 x to the 3/2 plus c. So let's go back, check our work. If I take the derivative of 2/3 x to the 3/2 plus c, am I going to get out the square root of x? So what do you guys think? Hopefully you think yes. Let's check. So the derivative of 2/3 x to the 3/2 plus c, by my derivative rules, I'm going to drop down that 3/2, so I'll get 2/3 times 3/2 x to the 3/2 minus 1, which is 1/2. And then the c goes away. Notice that this huge fraction here is going to multiply out to be 1. And so I'll just get out x to the 1/2 or root x, like I wanted. So big check mark. Last problem. If I have little h of x is equal to e to the 2x, find an antiderivative big H of x. And so when you see the problem written like this, what they're really saying is, hey, remember those integrals? Well, just put that little function in there. So do the integral of e to the 2x. And what you'll get by your formula is 1 over k. K is equal to 2 here, and e to the kx plus c. Let's check if it worked. If I take the derivative of this thing on the right-hand side, the 1/2 e to the 2x plus just some fixed number, maybe it's 32, maybe it's a million, who knows, do I get e to the 2x? And this is one we actually kind of already checked before, I believe. 1/2 e to the 2x plus c. I will in fact get out 1/2 2e to the 2x plus 0. The 2 and the 1/2 turn into a 1, and I get out e to the 2x. So big check mark. I take the derivative of this, I get that. Take the derivative of this, get that. And that's why it's called an antiderivative. We're doing the exact opposite of a derivative.